Let's see. I'll show you guys a video. I'm going to talk about oxidation. This aldehyde to this carboxylic acid. And I was trying to work this problem in class, and I had some problems, and it really just came down to I was sweating the little stuff. Shouldn't have been. So first I want to apply my oxidation rules, find the oxidation number of my carbon here. So I did it this way. And this is equal to 0. So 3x plus 4 equal to 0. And x then is negative 4/3. And then I did this one. Oh, that's equal to 0. All right. And so 3x equals negative 2, x equals negative 2/3. And I was caught up a little bit on the fact that these were fractions. I'm having trouble with that. But don't forget, when I do the balancing of this, it's the total charge that we're balancing. So here it's going to be 3 carbons times negative 4/3 for each one. And here it'll be 3 carbons times negative 2/3 for each one. And so now I got a negative 4, here I got a negative 2. We can see that we've lost 2 electrons, so I have to add 2 electrons to this side. And that makes things a little bit easier to balance. I also then have to add water to this side to get my oxygens equal. Now I've just added 2 hydrogens, so I'm going to add 2 hydrogens here. And then we could continue on. Now notice this was 2 electrons. I believe we had 6 electrons in the previous, so I'd have to multiply this whole thing by 3 to get my electrons to balance out. But I was caught up in this, forgetting this step right here. And so if you get a fraction for an oxidation number, it's really not a big deal because you're looking at the total oxidation numbers over here. And so the fact that this was a 3 really didn't affect the fact that all 3 of them collectively, we lost 2 electrons. All right. And so we could still see the flow of the electrons. We just get these fraction oxidation numbers. And don't let them scare you. I let them scare me. You saw what happened. Terrible. Terrible.